in order to solve this equation, our first step is to get this exponent piece by itself. So to get this by itself, I first have to get rid of that 300. So since it's held on by multiplication, I'm going to divide it off. Boom, it's gone. Got to do that to both sides. See that? Cancel those zeros. 60 divided by 3. Hopefully we can see that when we take 60 divided by 3, we can tell that would be 20. Alrighty, now we have this new equation. Now, to solve this, I have no more movement. This is all by itself, so I have to somehow figure out how to solve this. So what you're going to do is you're going to create this into a log. So this is going to look like log base 2 20 equals x over 12. Now, how do I change that to a log? Well, remember, we switch these two and put the word log in front. Alright, we switch these two and put the word log in front. Now we finish solving. So to finish solving this, I got to get rid of the 12 right here. So since it's divided by 12, I got to get x by itself. So if it's divided by 12, I multiply by 12. So if I multiply this by 12 and this by 12, I now have my answer. X equals to 12 log base 2 20. That would be your answer if you did not have a calculator. Now, if you could find the value of log base, let's say you knew that log base 220. Let's say you could figure out exactly what it is with a calculator. Let's say I knew it was 4.3. Now, can't you simply take, if this is 4.3, can't you go 12 times 4.3 to get your answer? So your answer would end up being 12 times 4.3, so times, let's make it a parenthesis, a little bit cleaner. That would be 51.6. So no answer, another answer could be 51.6. Now there is also another answer, okay, because there is a common way to rewrite this that we need to get used to. It's not, so make sure you can write it this way. And what you do, if I want to rewrite this you can rewrite as two separate logs. It's called a change of base formula. And I'm going to write my answer also as x equals, leave the 12 in front, but I'm going to split it into two logs. Okay, you write the top piece as one log and the 2 as another log, and you divide them. So this would be log 20 over log 2. So this is another way of writing that, but this is kind of cleaner. This is just what you'd use for most calculators to find the answer. And this is the decimal value. So you can choose kind of what you want to use, depending on the situation. Now in order to solve this problem over here, you do not need logs. You need another approach. The approach for this one is to try to get it each side so they have exponents with the same base. So we have to do some stuff to get the bases the same. And what I noticed first is they both have coefficients. So let's get rid of one of these coefficients. So if we divide both sides by 600 or 300, can we simplify? And what you should notice is if I divide both sides by 300, you will notice that that cancels. And so we will now have something that looks like this. Okay. Now, so we cancel that out, we now have this. Now, the bases still aren't the same. You can't just go multiply 2 times 2 and make it a 4. It doesn't follow the properties properly. So let's see, but I can make that 4 into 2 squared. So now my bases will be the same, but then I have this 2 out front. So here's what you kind of want to do. Let me make that multiply a little bit bigger. What you're going to want to do is you're going to want to write a 1 right there and realize that's 2 to the first. And then you also have to realize, well, if that's 2 to the first and that's 2 to this, if they have the same base, don't you add powers? So you should get something that looks like this. That's 2 to the 1 plus 4x plus 1. All right, we are allowed to add the powers if the bases are the same. All right, and over here, I want to write that as 4 squared. So 2 squared, sorry. So 4 is 2 squared. So I now have the same bases. Change that one and change that one. Now, when you take a power to a power, over here you're going to multiply. So when you take a power to power, you multiply. You just got to make sure you remember that. Over here you combine like terms, and when you combine like terms, the ones combine. So I have 2 to the 4x plus 2 equals, multiply the 2 times the x, leave the 2 on the base, but 2 times x is 2x, and 2 times negative 3 is negative 6. So all that work, and I now have the same bases. Now why is that useful? Well, if you have the same bases, well, 2 to some power equals 2 to some power. For these to be equal, you must realize the powers have to be equal. So what we can do is technically kind of ignore the bases and just, well, if I need the powers to be the same, can't I simply write an equation of the powers being the same? Because for the equation over here, or the expression over here, to equal the expression over here, the powers must be the same, and same means equal. And guess what? This is a really easy solve. So all this top work was just to get to the point same bases, and then we can solve. All right, let's solve. So I'm going to minus the 2x over, cancel that out, minus 2x, cancel that out. I'm also going to make this quicker, and I'm going to minus this 2 over, kind of speed things up. So what we got here is 4 minus 2x and a negative 6 minus 2. So it looks like we get a 2x equals negative 8. Then we divide by 2. And we get x equals negative 4 is my answer. If we were to take negative 4 and put it right here and here, both sides would be the same. So on these kind of problems, first get rid of any kind of GCFs if you can. Then you got to look at them and kind of think, okay, what would be a number? They both would be the same for the base, and this one I knew I could make it a 2 squared. Then you got to realize, okay, I can't just multiply those. I got to add the powers. And then here you have to know, oh, a power to a power I multiply. It's a lot of exponent properties, very intensive exponent properties. And when you get to this point, you just make an easy equation and solve. So this problem over here is getting exponent bases the same. This problem over here is getting to the point that you can make it into a log. So you don't need logs for this, and you do need them for this type. Basically, if there's one exponent, you're going to make a log. If there's 2 exponents, you're going to have to try to get the same base.